Today we're going to be digging more deep into the arithmetic and geometric sequences. So all you need is your note sheet and your pencil today. So as a recap, arithmetic sequence are sequences where we are adding or subtracting from the previous term, and geometric sequences are where we are multiplying or dividing from the previous term. Just like yesterday with the dominoes, we are multiplying by 1.5 in height to make it larger. That would be a geometric sequence. So today we're going to do a small little activity called Would You Rather? So would you rather have option 1, $1 million, or option 2, day 1, today I give you a penny, tomorrow I give you 2 pennies, on Thursday I give you 4 pennies, and so on and so forth. So I want you to take a brief moment, and I want you, without even doing any math, which option do you want to choose? $1 million, or I give you a penny today, 2 pennies tomorrow, Thursday, 4 pennies, and it continuously on. So now that you've thought about it, I know a lot of people are going to choose option 1, just straight up $1 million. Here you go, $1 million for you. Option 2, people say that, oh, well, I'm only starting with a penny, but you're going to be 2 pennies tomorrow and 4 pennies on Thursday, and it's going to keep increasing, and you're going to give me more and more pennies. But I also see the option of pennies aren't a big quantity of money. So what I need you to do is I want you now to use math, create a table, pause the video, and I want you to figure out how long until option 2 becomes a better option. So go ahead, pause the video, and start writing out a table. Alright, so now that you have paused the video, I'm going to go over question 2. How long until option 2 becomes a better option? So I created a table over here that I'm going to show you. So here's my table. On day 1, you got 1 penny. I gave you 1 penny, and on day 2, I gave you 2 pennies. So now you have 2 cents on day 2 because I gave you 2 pennies. On day 3, I gave you 4 pennies. And on day 5, how much do you think I'm going to be giving you? Well, I can see that there's a pattern here. Yeah, it's increasing by 2, but it's actually multiplying by 2. I'm multiplying by 2 cents. So each day I'm giving you times 2 cents. So again, I multiply times 2. Sorry, let me fix this. I'm giving you 2 more. 2 times 2 is 4. And if I multiply again, so this is a geometric sequence, you're going to have 16 cents. And then if we keep going, then you're going to have 32 cents. And it's just going to keep going and going and going and multiplying by 2. I can actually create an equation for this. It'd be a lot easier, especially if I want to know when it becomes a better option. So how I'm going to create my equation is this. It's increasing by 2 each time, correct? So I know it's increasing by 2. That's a kind of important number. Okay, this is essentially, call it your slope. It's increasing by 2 each time. So what I originally start with is 1 cent, because today I give you 1 penny. So if I was going to write an equation or a function, I would have f of x equals, remember f of x is just y. Remember, that's just what y is. Okay, so f of x equals how much I started with, 0.01. And what we're going to do is multiply it, because say here it says we're multiplying by 2. I'm going to multiply 2 times, multiply by 2, but because I want to figure out when it's going to be beneficial, I'm going to put this to the power of x. The x is the number of days, because it's multiplying times 2 each day. So obviously 2 times 1 is 2. So on the second day I had 2 pennies. And then 2 times 2 is 4. Then I have 4 pennies. And so on and so forth. So now if I wanted to figure out, let's say we go a whole month. So there's about 30 days depending on, or 31 days. We'll use this month of December as our 31 days. So what I can do is I want to figure out at 31 days, am I going to have more than $1 million, or less than $1 million, or somewhere in between? So I'm going to get my trusty calculator out. And of course, since now we're dealing with more numbers, we're going to be using the calculator a lot more. And since if we have smaller numbers, obviously like 1, 2, 3, 4, 5, we can easily figure that out. But since we have to the power of 31, we're going to do this. So how I'm essentially going to write this is f of 31. So at 31 days, where's my graph? How much pennies am I going to have? Or how much dollars? Because remember, after a certain point, our pennies turn into dollars and pennies. So now we have 0.01 times 2 to the power of 31. Remember, 31 is our days. So if I have 2 to the power of 31, what that's going to be is a lot of money. As you can see right here, that's more than my $1 million. And if I multiply it by 0.01, it's still more than $1 million. So now think about this. Would you want to change your mind? Would you just want $1 million right then and now? Or do you want to wait 31 days to accumulate more than $31? $1 million. So I'm going to throw in another mix. There's actually a third option that might be a little bit better. Let's see what that third option is. So option number 3. Here's a new choice for you. Since, waiting 31 days or however many days to get $1 million or just be handed it, how about this? What about $5,000 per day? Now, which would you rather have and why? So take a second, maybe calculate out a few days and see, maybe multiply 31 times $5,000. I don't know, I'm not directing you in any particular way. But if I was going to give you $5,000 a day, decide what you'd rather have. So now that you've decided what you'd rather have, I'm actually going to show you the video for the pennies. So here's what the penny video is going to look like. So obviously you can see what we originally started with. So remember, day 1, I give you 1 penny, 2, 4, 8. It's increasing and increasing and increasing. So let's see what the next week would be. By day 10, you'd have $5. By day 14, you'd have $81. So you only had to wait 4 more days to get $81. And then the next week, we're in the hundreds and then thousands of dollars. And as the month continues on, more and more and more pennies that you get. So at this point right here, at day 28, so you don't need to wait 31 days to get $1 million. At 28 days, we actually go over the $1 million mark. And if you really wanted to wait for 31 days, this is what it's going to be. So there we go, I calculated it correctly. So we have large numbers for our answers. So again, the answer to question number 2, how many days do you need to wait, would be 28. So I know how some of your brains work. Some really don't like multiplying that many numbers out, and I get why. It's super big numbers. But don't be scared. Some of you prefer more visual representation like the video. while others prefer a graph. So let's actually look at a graph and graph all three options. $1 million straight off the bat, a penny a day, essentially, and then $5,000 a day. So let's look at our graph. So straight off the bat, I'll tell you which color is which. So the green line right here is going to represent just giving you $1 million straight off the bat. Our blue line here is if I give you a penny a day. You see how after 21 days we're getting a lot more money, up in the hundreds and hundred thousands. And then if I gave you $5,000 a day, that's how it's going to increase. Each day you're going to get $5,000. So as you can see, the better option if you want more money, because at some point at 200 days, the $1 million is going to be kind of obsolete versus the penny a day versus $5,000 a day. But if you want more money from somebody, tell them you want a penny a day. It'll increase each time, because then the next day they get to give you 2 pennies, and then 4 pennies the next day, and then 8 pennies, and then 16, and so on and so forth. Whew, until they run out of pennies and have to go to the bank and question every bank teller why they're giving hundreds of thousands of pennies to you. But there's our graph. Take a second, pause, and look at the difference. And you can also click open on the slideshow too and see how the numbers are increasing, how many days, that kind of thing too. So for this next part here, you're going to determine if it's an arithmetic or a geometric sequence. So as you look at the bottom of your page, so for below, each of the quantities below identifies whether the changing quantity can be modeled as an arithmetic or a geometric sequence. So if I have a savings account which earns no interest and receives a deposit of $723 per month, if there's no interest happening, that means I'm not gaining any more money during the months with more money in it. So this one right here is going to be an arithmetic sequence. So again, arithmetic sequence. Because look, I'm increasing $723 a month. If I wanted to prove that, you can write that. You can also say y equals 723x, which shows that it's going to increase each month $723. You could also draw a table out if you would like of the first couple months. So the second one here, it says the value of a machine depreciates by 17% each year. Depreciate means that each year it's decreasing by 17%. It's getting a lot cheaper each month. So think about it like this. Gas prices, they usually decrease or increase each year by a certain number of percent. So this is going to be an arithmetic sequence because it's decreasing each year by 17%. So let's assume that the first year is at 100% and then it's decreasing 17%. So that means that it would be 83%, okay, or sorry, it would be $83 then. And then by year 3, if I subtracted another 17% from it, it would be at 66 and so on and so forth. So let's look at our next one. So I want you guys actually to do the rest on your own. I will post another video for the last few here, but you should be able to get a good idea of which is which. Also, don't forget that you have a checkpoint today as well.